Okay, here's the notes for today's lecture on isPrime and nthPrime. We're going to start by copying the notes out of the spring 2010 15110 notes that you know how to get to. And on the isPrime and nthPrime example, taken from the loops notes, we'll select all this code, we'll copy it, and we will go into, in this case, Dr. Java. You can use whatever editor you want, and we'll paste it. We're going to write isPrime, so I'll just delete it without looking at it. And later on, we're going to write nthPrime, so I will delete that as well. The reason we started with this, though, was we have some nice tests in here, and we'll start with those. So let's look at the test for isPrime. 2 is prime, 3 is prime. That means not right there, so 4 is not prime, 5 is prime, 6 is not prime, and so on. So how do we tell if a number is prime? What we do is we start checking the numbers between 1 and the number we're testing. So to test, for instance, if, say, 5 is prime, we'll see if 2 divides into 5. Is 2 a factor of 5? It's not. Is 3? No. Is 4? No. When we make it to 5, we sure don't check if it's a factor of itself, so we're done. And it's prime. On the other hand, if we check if 6 is prime, we immediately see that 2 divides into 6, so 6 is not prime. So what we're saying is we have to have a counter that goes from 2 up to and not including n. Okay, we know how to do that. We will have a counter of a for loop. The counter will start at 2 and it'll go, as long as the counter is strictly less than n, we'll add 1 to the counter. It's going from 2 up to and not including n. Okay, now each time we advance the counter, we have to check if it's a factor of n. If n, when we divide n by the counter, if the remainder is 0, that means we found a factor. In that case, if you find a factor, n cannot be prime, so simply return false. If we make it through the entire loop and we never found a factor, then we can return true, meaning we made it and it's prime. We can do better than this, but as the note says, do not worry about efficiency. We'll make it faster soon, probably Monday. But this works, or at least hopefully it works. We compile it, and we're missing a return statement in isPrime, return false, just for now. We compile it, and nthPrime, sorry, return 42. 42 is the nthPrime for all n. And now it compiled, and we run it, and it failed us. And if we look where, it failed us on an assertion error on line 28. Go to line 28, and there it is. And -3, according to our tests, turned out to be prime. Ugh. Well, that's why we have tests, to find bugs like that. And let's go here and look what happens when n is -3. Well, we run the counter from 2 up to n. Well, it starts out at 2, and 2 is already not less than -3. So we don't run this loop at all. And we just return true. That's the problem. We can take care of this by getting rid of all the prime numbers, all the possible numbers that we know aren't prime. If n is less than 2, it can't possibly be prime. So we'll go ahead and return false right here. Those are not prime. Go ahead and compile. Not only is this going to get the -3 case, it's also going to pick up the 0 case. And we crashed, but if you notice, we crashed in nthPrime. isPrime works perfectly. There it is. There's our isPrime. Beautiful. So now we have to write nthPrime. Okay? So now our nthPrime is going to look similar to the one from the notes, but actually different because for whatever reason, foolishly, those notes start with n of 1, not 0. And we don't like that. So we're going to actually claim that the 0th prime is 2. Then the nth prime when n is 1 should be 3, and so on. So we're subtracting 1 from these numbers. And another thing is, if you give us a negative integer, we'll just say -1. So because it makes no sense to have the -5th prime number. So notice I changed the test. I changed the definition of the problem. Let's actually change the problem. It returns the nth prime number or -1 if n is negative. Notice this is a slightly different definition. So say, for example, nth prime of 0 equals 2, and nth prime of 1 equals 3. Okay, cool. So now, the way you solve nth prime is as such. we'll have a counter start, just counting up. 1, 2, 3, 4, 5, 6. And we'll check if it's prime every time. Is 1 prime? No. Is 2 prime? Yes. And then we need to have a second counter that counts the number of prime numbers we've seen so far. And when we get to 2, since that's prime, we add 1 to that counter. We've seen 1 prime number. And then when we get to, say, 3, we check if that's prime. Yep, there's another prime number. 4, not prime. Okay, keep going. And so on until we've seen enough prime numbers. We'll reason through what that means in a moment. So we said we need a counter, and we also need the number of primes that we've seen so far. Number of primes, or maybe primes counter. Notice the code here, right here, could be very similar to, but slightly different from the one in the notes from 2010. All right, our primes counter is initially 0. We've seen, or maybe primes seen, maybe that's good. We've seen no primes. Now, should this be a for loop or a while loop? As we start counting up, it's true that we know that our counter is going to start at 1. It's true, or we can also start at 2 to tell you the truth, because we know 1's not prime. It's true we're counting up by 1s, but the problem is we don't know how far to go. Like the 43rd prime, where is it? If we knew, we wouldn't have to do this silly thing with counting. We don't know. And when you don't know how far you're going to count, you don't use a for loop, use a while loop. So long as we haven't seen enough primes, yeah, that's not Java, don't worry about it. It's just, we're going to fill that in later. As long as we haven't seen enough primes, what do? Well, we'll add 1 to our counter. So our counter had better start out at 1. We'll check if our counter is prime, okay? And if it is, by the way, you can say if is prime counter, which gets, if this is true, goes into the body and runs this here. But you can also be explicit and test if it equals true. In the old days, people said testing if it equals true was a sign of bad programmers or novice programmers. These days, I don't think it's true anymore, and I think that can actually be considered clearer code. I like this code. There are people who don't, they prefer it this way. You can do it either way you want because they're literally the same thing, because the only way isPrimeCounter can equal true is if isPrimeCounter is true itself, and if it's true, we can just go ahead and do that. In any case, we get inside here because we saw a prime. Well, naturally, primes seen would be plus plus, or if you rather, plus equals 1. We saw another prime. Let's remember, we just saw a prime. So we keep marching ahead as long as we haven't seen enough primes. So when do we stop? Well, you might think it's as long as the number of primes I've seen is less than n, the number of primes I want to see. And then when I'm done, return the answer, whatever that is. Now, that's not going to work because when I'm looking for the 0th prime number, which should be 2, when I get in here, let's see, I set my counter to 1, prime seen to 0. Is 0 less than 0? It is not. And so we won't run the loop at all, and we'll simply return 1. So we have to, for sure, keep going till we see the first prime, the 0th prime. So this is probably less than or equal to. You want to keep going till the primes you've seen is actually greater than the one you're looking for, because we start at 0. And what I just discussed is the way you logically reason that through. Great, so now we know that we're going to go long enough. Well, what happens when we're done? Where's the answer? Well, let's see, let's walk through. When n is 0, counter is 1, prime seen is 0, 0 is less than or equal to 0. Counter becomes 2, 2 is prime seen becomes 1, kick back to the top, 1 is not less than or equal to 0, fall down here, and the answer is the last value we checked is prime, which is the counter. Let's go ahead and compile this. It compiles and run this, and it does not run. It crashed on line, see right there, 64. So the test that we failed on is the -5, -1. Okay? Well, where here do we return -1? We don't anywhere. So that we said right here, -1 if n is negative. We forgot to account for that. You can do that right off the top. You can simply say if n is negative, then go ahead and return -1. Now we compile that, and we run, And we are done. That's all you need to know for this part of the lecture. I'm going to post this code for you in addition to the video. I would highly recommend that you study this code and be able to reproduce any and all of it from scratch for class on Monday. You should work with your partner over the weekend to be sure that both of you are ready on Monday to have, say, a quote-unquote pop quiz. I say quote-unquote because here you know it's coming, that I should say write isPrime or write nthPrime, and you'll be able to write the code. And when I say nthPrime, I mean this nthPrime right here, not the one from the 2010 notes. All right, sports fans, good luck. Post to Piazza if you have any questions.